Part 271, line 22f1fa6, Super Cobalt-Base Prealloyed Powders, TAZ-8A, NASA 5G Wow Seti. There's the alien radio signal. And processing techniques for the extrusion of superalloy powders from G.I. Friedman, 1968. Whitaker Corp. J.C. French made evaluation of a cobalt-based alloy HS31 made by extrusion of prealloyed powders from J.C. French. R.L. Ashbrook, Tech Rep number 7019 ASM, Capta.com, 1970. Evaluation of a cobalt-based alloy HS31 made by extrusion of prealloyed powders. J.C. French, R.L. Ashbrook, W.J. Waters Tech, and it's from Ohio. Powder technology. Nickel-based alloys for aerospace applications from J.C. French, NASA Special Publication, 1970, adsabs.harvard.edu, and that's from scholar.google.ca. Next is effective autoclave heat treatments on the mechanical properties of the prealloyed powder cobalt-based alloy HS31. J.C. French, R.L. Ashbrook is 1973 from en.scientificcommons.org. Next is all four versions of novel applications for TAZ-8 from S. Riddlebaugh, NASA in Washington from 2001 and in 1991 as well. Recent needs in the non-aerospace industrial sector have revitalized interest in high-performance alloys. TAZ-8A has a combination of properties that makes it unique: a high temperature strength, oxidation resistance, abrasion resistance, and exceptional thermal whatever. So scholar.google.ca. Next is development of a nickel-based superalloy using statistically designed experiments from H.E. Collins and R.J. Quigg, 1968. Next is strength enhancement process for prealloyed powder superalloys from W.J. Waters, 1977, CSA.com. A technique involving superplastic processing and high pressure autoclaving was applied to a nickel-based prealloyed powder alloy. Tensile strengths as high as 2865 mn square meters at 480 C were obtained with AS superplastically deformed material, appropriate treatments yielding. Next is application of directional solidification to a NASA nickel-based alloy TAZ-8B from J.C. French and W.J. Waters from NASA. 1968, papers.sae.org. Abstract is a nickel-based alloy TAZ-8B has been developed which compares favorably in the high temperature strength with known high strength nickel-based alloys. Although basically a cast material, the alloy also possesses workability potential. Next is that the National Aeronautic and Space Engineering and Manufacturing meeting a number of advanced aerospace vehicles require the use of light. That's from NS Sheet from 1964. Next is the development of advanced jet engines with long design lives has aroused interest in the mi-crostructural stability of these superalloys. R.L. Dreshfield, 1968. Effective casting geometry on mechanical properties of two nickel-based superalloys from J.R. Johnson and R.L. Dreshfield from 1976. That's CSA again. An investigation was performed to determine mechanical properties of two random-free modifications of alloy TRW and to evaluate the suitability of the alloy for use in a small integrally cast turbine rotor. The two alloys were initially developed using stress rupture. Next one is a book. It's Trends in Usage of Hafnium on google.ca. The next one is National Research Council, U.S. Committee, 1968. As a part of the National Research Council, the Materials Advisory Board performs study, evaluation, or advisory functions through groups composed of individuals selected from academic, governmental, and industrial sources for their competence or interest in the scholar.google.ca. So here's the tags and keywords: superalloy powders, cobalt-based alloy HS31, nickel-based alloys, aerospace, prealloyed powder, cobalt-based alloy HS31, TAZ-8A, high temperature, strength, oxidation resistance, abrasion resistance, thermal superplastic processing, high pressure autoclaving, nickel-based prealloyed powder alloy, tensile strengths as high as 2865 Mn square, M at 480 C, directional solidification, National Aeronautic and Space Engineering Manufacturing jet engines, mi-crostructural stability of the superalloys. So we're going to go on to the next video.